From the general form of a quadratic equation ax squared plus bx plus c, we can get this really useful quadratic equation, which is x equals minus b plus or minus square root of b squared minus 4ac by 2a. I know. This formula has been memed to the death to show the useless things schools would teach you, but the way this formula is derived is pretty elegant, and I suggest you watch the process on YouTube. And I want to focus on this b squared minus 4ac part inside the square root for a second, because its outcome will tell us what kind of roots the x value is. For example, if the outcome value, or b squared minus 4ac, is positive, this part is going to produce a square root value of that answer, and since that square root will either be added or subtracted to the rest of the formula, we'll obtain two real and different x valued roots. In addition to this, if the outcome value, or b squared minus 4ac, is 0, this part will become 0 because the square root of 0 is obviously 0. And when you add or subtract 0 to the rest of the formula, nothing really changes, so we will obtain only one real definitive x value. This is also known as equal roots. So if you see b squared minus 4ac as greater than 0, greater than or equal to 0, although we don't know if there's one or two definitive roots, we can always infer that the roots are real. We know that the square root for a negative value does not exist, so we can immediately conclude that no roots of it will be real. And for a sneak peek into advanced maths, because the square roots of negative values doesn't exist in the real world, they're called imaginary numbers, and we'll obtain imaginary roots. It is honestly surprising that those imaginary numbers have real effects on the world, but we are getting sidetracked, so let's move on. This is why b squared minus 4ac is called the discriminant, because its value will determine what kind of values the x values obtained will be. Let's do one example. Here is the question that asks us to find the values of k if the quadratic equation x squared plus k plus 2x plus k plus 5 has equal roots. Right off the bat, the question already told us that the quadratic equation has equal roots, so we can assume that b squared minus 4ac valued of the equation will be equal to 0. Comparing this equation of the general equation of ax squared plus bx plus c, we can see that the value of a would be 1, the value of b would be k, and finally the value for c would be k plus 5. Let's just substitute these values into b squared minus 4ac equals to 0, and we'll get k plus 2, the whole squared minus 4 times 1 times k plus 5 equals 0. K plus 2 the whole squared would give us k squared plus 4k plus 4, and k plus 5 times 4 would give us minus 4k minus 20. The 4k's cancel each other out. 4 minus 20 is minus 16, and we would get k squared minus 16 equals 0. We'll add 16 to both sides, so we would end up with k squared equals 16, and therefore we'll get the two values of k, which is plus or minus 4. And there we have it. We have found the value of k that would give the quadratic equations equal roots, or in other words, the value of k that would make the determinant 0. So in conclusion, if b squared minus 4ac, or the discriminant value, is less than 0, there are no real roots. If it is greater than 0, there are real roots. If it is 0, there are real equal roots. And if it is larger than 0, there are two different roots.